So we finally talk about vapor pressure. We've alluded to it a couple of times, but now we're going to go into what it means, how it changes, and what it's related to. So by definition, vapor pressure is the pressure of a gas in dynamic equilibrium with its liquid. So we have had a trend, right? Vapor pressure increases with decreasing IMF strength. The vapor pressure also depends on temperature, not surprisingly. Right? At higher temperature, you have more molecules that can escape the surface, and you end up with a higher vapor pressure. And as the temperature goes up, the vapor pressure will go up. Until you reach the boiling point. And I am now going to give you a definition of boiling point, which you probably never thought that you needed. It's the temperature at which things boil. But it actually has a formal definition. So I'm going to give you a definition for boiling point and then also for normal boiling point. So boiling point is the temperature at which a liquid's vapor pressure equals the external pressure. So when the vapor pressure equals the external pressure, that is when something is boiling. So a normal boiling point is going to look much the same. So temp at which vapor pressure equals, for normal boiling point, it's 1 atmosphere. So you can have a boiling point at any pressure, and you can, including 1 atmosphere, it's just that when it's at 1 atmosphere, we call it the normal boiling point. So the boiling point changes with pressure changes. We're going to give you an equation that relates to that. But first, some examples. So in Boston, which is at sea level, I think St. Louis is pretty close to sea level as well. Right, the boiling point is what you would expect it to be. It's 100 degrees C. In Denver, which is Mile High City, 5,280 feet above sea level, the pressure is lower, so the boiling point is lower. The boiling point in Denver is only 94 degrees Celsius. So this is why you start to see things like high altitude baking instructions. So if you are at a high altitude, the pressure is lower, your water boils at a lower temperature, you may have to cook it longer to get enough energy transferred to fully cook the food. Now, if you go up even higher, let's say that you go up to Mount Everest, which I don't have a height for, but you can imagine it's taller than Denver. Water at the top of Mount Everest boils at 78 degrees C because the pressure is so low. So the relationship between temperature and boiling point, we use something called the Clausius-Clapeyron equation. And like so many equations that we have looked at recently, there is a single point form and a double point form. So the single point, which, just like all of the other equations we've looked at, we will not use the single point probably for anything this semester, but it will show up in your reading. It is useful. Like most other cases, you usually gather the data and then make a plot, and then you're looking to get things like the slope and information that's contained in the slope out of that equation. So the single point form is that the natural log of the pressure is equal to negative delta H of vaporization over R times 1 over T plus the natural log of beta. And we haven't talked about beta at all. It's just the intercept. It's nothing we use, so we don't use this. What you would most often do is use the slope of the line to get the delta H of vaporization. So if you just want a pressure value or a temperature value, the single point form is not the form for you, because you would need to know what beta is, or have some kind of information about the intercept, or have enough data points that you could make this straight line plot of natural log of pressure versus 1 over T in order to get that information. So what we more often use is the 2-point form. And so the 2-point form is natural log of P2 over P1 equals negative delta H of vaporization over R times 1 over T2 minus 1 over T1. So if you know the enthalpy of vaporization and you know, say, the normal boiling point, you could find the boiling point at any other temperature, or you could find the pressure that you need to lower it to in order to achieve a specific boiling point.